All right, so light emitting diodes, LEDs. These are things that you have in many of the electronics that you have in your home. LED TVs have become very popular. They're very energy efficient. These are definitely things that we're going to look at putting in our circuit diagrams. So an LED is a diode, meaning that it has to be wired a certain way within a circuit for it to work properly. An LED itself has a positive and a negative side to the bulb itself. So an actual kind of lifelike diagram of an LED, to me they kind of look like jellyfish. Right? Here's the bulb itself, and you have two legs where one side is longer than the other. And one of these is the positive side of the LED, the other is the negative side. The positive side, called the anode, is always the long leg. So this is my anode. And the negative side is the shorter end in our lifelike diagram. This is called the cathode. And these are terms that you may have heard in chemistry, hopefully. Right? But the positive and the negative side of these are very important. So this is the lifelike diagram of my LED. When we start putting LEDs in circuits, we're not going to just draw them like a light bulb, because a light bulb doesn't have a positive and negative side. You can wire a light bulb in a circuit either direction, right, essentially, right, as long as you have metal touching metal. Unfortunately, we have not gotten to build an actual physical circuit in the classroom together. Hopefully, one of these days we'll get to do that. But if not, light bulbs don't need to be wired a certain way. LEDs do. So this is my lifelike diagram. If I give you the schematic diagram for an LED, here's the wire, right, itself that you just kind of connect. An LED has a cathode, which in my schematic looks like this, and an anode is the other side. Okay, so this is what an LED looks like in a circuit diagram. This vertical, the way I've drawn it, the vertical line, this is my negative side. And you see that there's kind of like a triangle here. The flat side of this triangle would be my positive side. Okay. And so we would connect this to an actual circuit. So I could continue this right here. There's my LED. Remember, to make a working circuit, I need to add a battery. So let's put a battery here. And then I could just close the circuit. So I have a circuit with one LED in it. Now, the way that I've wired this is very important. So you'll see if we look at the way I've drawn my battery, this is my negative side, right, the short line. Here's my positive side. Remember, we follow the flow of electrons, so electrons are going to leave the negative side of the battery. Right, these are my electrons. And they are going to meet the negative side of the LED, travel through the LED, and then go back to the battery. This is wired properly. So the negative side of the LED needs to be connected to the negative side of the battery. If you were to flip that around, so I'm going to continue to draw another diagram over here. If I were to draw my same battery, right up here I'll have my LED, but I'm going to flip my LED, right? So now the anode is meeting the negative side of the battery and the cathode is meeting the positive side. Electrons are still going to go this way, right? They're going to travel in a clockwise direction, but since my LED has been wired improperly, essentially it's backwards, the entire circuit will not work. Right? So the way that you wire an LED is extremely, extremely important. Another thing to consider, since we have talked about series and parallel circuits already, if I put an LED in a parallel circuit, you have to, again, be very careful how you, leave that one up there, how you wire them. So let's build, we'll build a circuit this way. Right, so here is my battery. We'll put an LED here and go back to the battery. And then I'm going to continue to build a circuit. Let's put another LED here. And we'll just put a regular light bulb in here as well. Okay. So now I have a parallel circuit. I'm still going to have current that flows in a clockwise direction here. And here's, we'll call this LED 1. So current will travel down through here. This is my negative side, this is my positive side, and back to the battery. But if you look at my second branch here, current will not travel down through this LED because it's been wired improperly. So it's kind of like this entire branch does not exist. So current will just continue, travel through the light bulb, and then go back to the battery. So in some of the problems that you're going to see, you have to be very careful. Look at the direction that the LED has been wired, because sometimes, depending on where the LED is, the entire circuit will not work. Right? For instance, if I were to erase here and wire an LED in this direction, if you take a second to analyze that, if you look at the current, right, it's going to travel through here, get to this point, and this is the positive side of my LED. So nothing is going to flow through this, which means I essentially have a short circuit here, right? Because it's placed so close to the battery, the entire thing will not work. So some of the problems that you're going to be looking at, make sure you definitely look at the direction of an LED. Right? LEDs are treated just like other components of our circuit. They will have a certain resistance. They will use a certain amount of the potential, so they will have a potential drop associated with them. And the similar relationships still occur. So if you wire them in series to find total resistance of your circuit, you're going to add up your resistances of your LEDs. If you wire them in parallel, again, all those same relationships still apply for current, resistance, and the potential difference and potential drops.